In Unit 6 and 7, we are continuing with systems of equations a little bit by talking more about matrices. So we did basic matrices in that we use them to solve systems of 3. Okay, that's all we've done with them. I am not going to have you do everything by hand with these. There's going to be some things that we do by hand, mainly because it's easy. And then there's other things we're going to do in our calculator using matrices. And we'll kind of do some more system stuff with this, with systems of inequalities and shading and stuff like that. So that's kind of where Chapter 6 and 7 is headed. There, at the beginning, is like little to no word problems. There's a few at the end, not a lot. Okay? All right, so to begin with, we're just going to talk about some basic matrix vocabulary. This will be kind of like different as far as what we have to talk about, because there's not a whole lot of math today necessarily. It's a lot of vocabulary and just learning how to talk about matrices. So the first thing is that we need to talk about the size of matrices. So a matrix is made up of a certain number of rows and a certain number of columns. Okay, so if we just say it generically, we would say M by N. To say that it's a different number of rows than columns. Sometimes it's the same, sometimes it's different. So we would say it's an M by N matrix or a matrix of size M by N. There's this little notation going on here that is this. Okay, this is confusing to us at the beginning. A sub I J. It looks like it is a number. Like, for example, it looks like we're looking at that and saying that's A sub 11. It is not A sub 11. It's A sub 1, 1. Okay, and I know that means the same thing as 11 to most of us, but realize that the first number is saying what row it's in. The second number is saying what column it's in. So that means this is whatever is in row 1, column 1. Therefore, the second one is whatever is in row 1, column 2, and so on, the whole way out. One as well. This should be A sub 2, 2 right there, because it should be the thing that is in row 2, column 2. The reason we talk about that is because I can refer to like what is in that spot by using that notation, and you will see that in example 1. So in example 1, we have a small matrix down here. It has how many rows in this A? 1 row. How many columns?
3.
Okay, so we would call this 1 by 3. And then this is this notation right here. So that notation is saying what is in row 1, column 3. Okay, so if I look at the matrix that I've been given, row 1, column 3 has what number in it? 0. Okay, so then if I look at B, how many rows does that matrix have? 3. And how many columns? 2. So I would call it 3 by 2. So then using that same notation again, A sub 2, 1, I look at row 2, column 1. What number is there? 5. And C is a special matrix. It's a very teeny tiny one. It has how many rows, how many columns? 1. 1 by 1. We won't talk about A sub anything there because there's only one entry. And then D. How many rows, how many columns? 3 by 5. And what number is in row 3, column 2?
-2.
-2. Nice and easy for a Thursday here?
Yeah.
Okay, it's almost Friday, isn't it? A couple of vocabulary terms below as we continue to talk about what matrices are. Number 1, a square matrix is same rows as columns. So a 2 by 2, a 3 by 3, a 4 by 4, something like that. Okay? You'll see this on your homework. If it says order a certain number, order 3, order 4. That is a shorthand way of saying 3 by 3, 4 by 4. Okay? Every square matrix has what we call a main diagonal. The main diagonal is highlighted there. It's from corner to corner, left to right. It divides your matrix in half. We then say that you can either have an upper or a lower triangular matrix. So if something is an upper triangular matrix, it means from that main diagonal up to the top right corner are where your numbers are. Everything else below that would be zeros. Lower triangular is the exact opposite. All of your numbers are main diagonal and below, and the rest of it is zero. One other special term is calling something a row or column vector. It's if it has just one row or one column. So like A would be a good example of a row matrix because it has only one row. A column matrix you could say is C. C would be a column or a row matrix because it has only one column, one row. Okay. Now we're going to talk a little more vocabulary on the back and how to construct some matrices yourselves using rules. The main part of this today is just learning how to talk about them, which makes life kind of easy. So in part A now, we're going to jump into creating our own matrices given like the information that they ask for here. So first, A asks us to construct a 3-entry column matrix. So we just talked about column matrix. What does that mean? Only one column. So I have one column, 3 entry. Means I have 3 spots in it to fill. Now, the other parts they tell me. A sub 2, 1 is 6. So where do I put the number 6? Second row, first column. There's my 6. Now, this notation over here we haven't seen yet. A sub J 1. They didn't tell you what row it is, right? That means any other row. So they already told me row 2, column 1 is 6. Any other row they're telling me should be what number? 0. So you fill in zeros in any other row. Now we're going to jump into one with a different type of makeup here. First, B tells me A is what size? 3 by 4. All right. So here's how I want to start out. I want you to draw me, and if you're writing in pen, you might want to just make sure it's either erasable or hang on and just watch us for a minute. We're going to start off by just naming our entries. So I'm going to call this A11, row 1, column 1, A12, A13, A14, and so on. I have 3 rows, 4 columns. Can we fill these in? Okay, so A21, A22, and so on. Now, this is not how this is going to stay. This is just kind of my setup. After we do 1 or 2 of these, you may not have to think this way, but for the moment, I want you to think about each one of these one at a time. Okay? The generic notation for any entry is A sub I, J. I is the row number, J is the column number, right? So what they're doing is they're giving you a formula to fill in your matrix. And here is your formula. They're saying any entry, you are going to take that entry's row and column number and add them together. So for this first one, A sub 1, 1. Row number is what? 1. Column number is 1. If I add them together, I get 2. So instead of having that be A sub 1, 1, we're going to put the number 2 in that spot, according to that formula. So if I keep going through the formula, the next one next to it would be what number? 3. The next one after it would be what? 4. And after that, 5. And then I can go through each one of these and add together the row and column numbers instead of those A sub whatevers. Does that make sense? Okay, so take a minute and finish that one out. All right, so once you've filled in those numbers, that's the matrix you create according to those rules. So real quick, because this, if anything, I'm going to use air quotes on this one and say it's the hard thing of today. Like, this is not hard, but this is like what would be the hard thing of today. Okay, so real quick, I'm just going to give you a second example here. Okay, so find yourself a little bit of blank space in the bottom right, maybe because there's not a lot there. So I would like you at your tables. I'm going to say A is 2 by 4. And I'm going to give you this formula for it. Okay? All right, so just to make sure we kind of filled in the A sub things and then use the row number as your I, the column number as your J, use your formula. Why are we lost? If you have two matrices that are the same size and they are equal to each other, then their corresponding pieces are equal. Okay? So that means this X is equal to what? 2. Yay. This one, Y plus 1, is equal to 1, which tells me that Y is equal to 0.
You got a little too excited there.
2Z is equal to
3.
6, so Z is equal to 3. And 5W is equal to 0.
Too fast.
So W is 0. Those are easy.
Do we have to write it out or can we just?
No, I'm good if you just like solve. I'm just showing it. Literally, the corresponding parts are equal. Solve any equations that come from that. Okay? We're going to quickly talk about this last question and then 6.2 because it's addition and subtraction. We're going real difficult today. Yes, ma'am.
If you major in business, you do this.
There's a little bit of this, yes, because of what will come after this. So yeah, I'm a big fan of matrices. I like them.
What is this like used for? Like actually applicable? Like
This thing right here, A transpose. A transpose by itself has no like use, but we're just learning what to do with it right now. A transpose of a matrix, it takes the rows and makes them columns. So it kind of takes it and flips it on its side. Okay, so what this is going to look like. If I asked you the size of A, the way it is right now, you would tell me this is what? 2 by 3. A transpose, by definition, is the flip of that. It is 3 by 2. So you set it up as a 3 by 2. It takes the first row and makes it the first column. So instead of it being 1, 2, 3 across the top, it's 1, 2, 3 down the first column. Instead of 4, 5, 6 in the first row, it's the first column. Flips it on its side. Now, like I said, the first 2-3 days of this is going to be a lot of just doing random things with matrices. And that's okay. Live in this and be happy with it because it's easy, right? Then we'll jump into at the end, what are we going to use this for? So the last thing we're going to do today is some basic matrix operations. So yes, some of your homework is going to be like what we just covered there, okay? It's a lot of questions, but a lot of them are very quick questions, I hope. That's kind of the goal. 6.2 is basic addition and subtraction, which is why we do it with this day as well, because it's very short and easy. The basic rule for matrix addition and subtraction is they must be the same size. Okay? That does not apply for matrix multiplication, and that's why matrix multiplication is a separate day. Okay? But that means if I look at A and B, which of these two can I add or subtract? A. I can have no answer to B. I can't add those together because they don't have corresponding parts. It's like, what would I add to what? A, very straightforward. Add together the corresponding parts. So 1 plus 7 is 8. -2 and 4 gives me 2. I don't think I gave myself enough space here. It's actually not. 5 plus 4 is 9. 3 plus 3 is 6. 6 plus 0 is 6. Yay! We want stuff to be that easy. Yes? 6.2. Yeah. Yep. All right, scalar multiplication works the same way. If you look at example 2 here, 2 times the matrix A literally means multiply everything within it by 2. I know, shocking. Very difficult here. 1/2 times A means multiply every number within by a half. So that would be 2 and -1/2. And then the last one would be -A is just multiplying everything by -1. Yeah? That's C. Got like 2 more questions and I'm done. I know, I told you I was going easy today. I know, we have a lot of time. Yeah, got lots of time. -A for C would just be flipping the signs. All right, I want you to do 3A. It's just subtraction. And then we will talk 3B together and I will be done. All right, check your answer to A. Honestly, the only places people go wrong on ones like those is forgetting like the minus and negative and screwing that up. Not real difficult, but just that's where we would go wrong if we had one. Now, what happens is we can start putting stuff together and B kind of gives you a taste of that. It's not hard, it's just following things through one piece at a time. So first, if I'm given these 2 matrices here, I have A and B. They would like me to find this. Okay? So what you do is you just take it one piece at a time. First, this means A transpose, right? What did we just say the transpose means? It flips, right? So A transpose takes the first row of A and makes it the first column. It takes the second row, makes it the second column. Next, I would say, okay, now they want me to find 2B. Okay, so 2B is just taking B and multiplying it by 2. And then the last thing that I need to do is subtract. So 6 minus 6 gives me 0. 2 minus a -6 gives me 8. 0 minus 2, -2. -1 minus 4. All right, any issues with matrices? No? Easy?